variable frequency drive enclosure can sometimes be considered a motor control center. A motor control center is defined as an assembly of one or more enclosed sections having a common power bus and principally containing motor control units. Considering the characteristics of the variable frequency drive enclosure, it is an enclosed assembly. It contains multiple variable frequency drives. Each variable frequency drive has overcurrent protection, control wiring, and the frequency drive itself, and the dimensions are comparable to small motor control centers. Several factors need consideration. Firstly, the number of variable frequency drives. If the variable frequency drive enclosure contains multiple variable frequency drives, it is more likely to be classified as a motor control center. Secondly, a common power bus. If the variable frequency drives share a common power bus, it further supports the classification as a motor control center. Thirdly, additional components. The presence of additional components commonly found in motor control centers, such as disconnect switches or circuit breakers, would strengthen the case for considering it a motor control center. There are benefits of classifying as a motor control center. Firstly, standardization. Motor control centers are industry recognized and have established standards for safety and reliability. Secondly, coordination. Motor control centers allow for the coordination of multiple motor controllers, ensuring proper operation and protection. Thirdly, space optimization. Motor control centers provide a compact way to house and control multiple variable frequency drives. The specific requirements for classifying an enclosure as a motor control center may vary depending on local regulations and codes. It is always recommended to consult with the local authority having jurisdiction for final determination. Overcurrent protection is a critical aspect of both variable frequency drives and motor control centers. It safeguards the equipment and personnel from electrical faults that can lead to damage or injury. A variable frequency drive typically includes built-in overcurrent protection to protect its internal components and the connected motor. This protection is designed to quickly disconnect the power supply in case of a short circuit or excessive current draw. Motor control centers also incorporate overcurrent protection devices such as circuit breakers or fuses to protect each motor control unit and the common power bus. These devices are selected based on the motor's full load current and the applicable electrical codes and standards. Control wiring is another essential element in both variable frequency drives and motor control centers. It facilitates the communication and control between different components, enabling the system to operate as intended. A variable frequency drive uses control wiring to receive commands from a control system, such as a programmable logic controller, and to provide feedback on its status and performance. This wiring typically includes analog and digital signals for speed control, starting and stopping, and fault indication. Motor control centers also employ control wiring to connect the motor control units to a central control system. This wiring enables remote control and monitoring of the motors, as well as integration with other automation systems. The dimensions of a variable frequency drive enclosure can be a significant factor in determining whether it can be considered a motor control center. Motor control centers are typically larger than individual variable frequency drive enclosures, as they need to accommodate multiple motor control units, a common power bus, and additional components. If a variable frequency drive enclosure has dimensions comparable to those of a small motor control center, it is more likely to be classified as such. However, size is not the only determining factor, as the internal components and functionality also play a crucial role. The presence of multiple variable frequency drives within an enclosure is a strong indicator that it could be classified as a motor control center. Motor control centers are designed to house and control multiple motor controllers, providing a centralized location for power distribution and control. If a variable frequency drive enclosure contains multiple variable frequency drives, it suggests that it is intended to serve a similar purpose. However, the number of variable frequency drives is not the only factor to consider, as the enclosure must also have a common power bus and other features commonly found in motor control centers. A common power bus is a critical feature of a motor control center. It provides a centralized source of power for all the motor control units within the center. The common power bus is typically a set of copper or aluminum busbars that are connected to the main power supply and distribute power to the individual motor control units through circuit breakers or fuses. If a variable frequency drive enclosure has a common power bus that serves multiple variable frequency drives, it is more likely to be classified as a motor control center. The presence of additional components commonly found in motor control centers, such as disconnect switches or circuit breakers, can further strengthen the case for considering a variable frequency drive enclosure as a motor control center. Disconnect switches provide a means to safely disconnect the power supply to the motor control units for maintenance or troubleshooting. Circuit breakers provide overcurrent protection for the motor control units and the common power bus. If a variable frequency drive enclosure includes these additional components, it suggests that it is designed to function as a comprehensive motor control center. Standardizing motor control equipment offers several benefits, including improved safety, reliability, and maintainability. Motor control centers are industry recognized and have established standards for design, construction, and testing. These standards ensure that the equipment meets certain safety requirements and performs reliably under various operating conditions. By classifying a variable frequency drive enclosure as a motor control center, it can benefit from these established standards, leading to improved safety and performance. Coordinating multiple motor controllers is essential for ensuring proper operation and protection of a motor-driven system. Motor control centers provide a centralized location for controlling and monitoring multiple motors, allowing for coordinated starting, stopping, and speed control. This coordination can help to prevent overload conditions, reduce energy consumption, and improve overall system performance. By classifying a variable frequency drive enclosure as a motor control center, it can facilitate the coordination of multiple motor controllers, leading to improved system efficiency and reliability. Optimizing space is a common goal in industrial facilities, where space is often limited and valuable. Motor control centers provide a compact way to house and control multiple variable frequency drives, reducing the amount of floor space required compared to individual variable frequency drive enclosures. This space optimization can be particularly beneficial in facilities with limited space or where it is necessary to maximize the use of available space. By classifying a variable frequency drive enclosure as a motor control center, it can contribute to space optimization and improve facility layout. Local regulations and codes play a crucial role in determining whether a variable frequency drive enclosure can be classified as a motor control center. These regulations and codes may specify certain requirements for motor control centers, such as minimum size, component specifications, and safety features. It is essential to consult with the local authority having jurisdiction to determine the specific requirements that apply in a particular location. The authority having jurisdiction has the final say in determining whether an enclosure meets the requirements for a motor control center. Consulting with the authority having jurisdiction is essential for ensuring that the equipment complies with all applicable regulations and codes. This consultation can help to avoid costly rework or delays and ensure the safety and reliability of the electrical system. Variable frequency drives are electronic devices that control the speed of an alternating current motor by varying the frequency of the power supplied to the motor. They are commonly used in industrial applications to improve energy efficiency, reduce mechanical stress on motors, and provide precise speed control. Variable frequency drives typically consist of a rectifier, which converts alternating current power to direct current power, an inverter, which converts direct current power back to alternating current power at the desired frequency, and a control system, which manages the operation of the rectifier and inverter. Motor control units are the individual modules within a motor control center that control and protect individual motors. Each motor control unit typically includes a circuit breaker or fuse for overcurrent protection, a contactor for starting and stopping the motor, and overload protection to protect the motor from overheating. Motor control units may also include additional components such as pilot lights, push buttons, and meters to provide local control and monitoring of the motor. Disconnect switches are manually operated switches that provide a means to safely disconnect the power supply to a motor control unit or other electrical equipment. They are typically used for maintenance or troubleshooting purposes, allowing workers to isolate the equipment from the power source before performing any work. Disconnect switches are designed to provide a visible and reliable means of disconnection, ensuring the safety of workers. Circuit breakers are automatic switches that protect electrical circuits from overcurrent conditions. They are designed to trip and interrupt the flow of current when the current exceeds a predetermined level, preventing damage to the equipment and reducing the risk of fire. Circuit breakers are resettable, allowing them to be used repeatedly after an overcurrent condition has been cleared. These are overcurrent protection devices that consist of a fusible link enclosed in a protective housing. When an overcurrent condition occurs, the fusible link melts, interrupting the flow of current and protecting the circuit. Fuses are typically used in applications where a fast response to overcurrent conditions is required. Programmable logic controllers are industrial computers that are used to automate and control industrial processes. They are programmed using a specialized programming language and can be used to control a wide range of equipment, including motors, valves, and sensors. Programmable logic controllers are commonly used in motor control centers to provide advanced control and monitoring capabilities. Analog signals are continuous signals that can vary over a range of values. They are typically used to represent physical quantities such as temperature, pressure, or speed. In motor control systems, analog signals are often used to control the speed of a motor or to provide feedback on the motor's performance. Digital signals are discrete signals that can only have two values, typically 0 or 1. They are used to represent on-off states or to transmit data between devices. In motor control systems, digital signals are often used to start and stop motors or to indicate fault conditions. Energy efficiency is a critical concern in industrial facilities, where energy costs can be a significant expense. Variable frequency drives can improve energy efficiency by allowing motors to operate at their optimal speed, reducing energy consumption compared to traditional motor control methods. By classifying a variable frequency drive enclosure as a motor control center, it can facilitate the implementation of energy-efficient motor control strategies. Mechanical stress on motors can lead to premature wear and failure. Variable frequency drives can reduce mechanical stress on motors by providing smooth starting and stopping, reducing the impact of sudden acceleration and deceleration. By classifying a variable frequency drive enclosure as a motor control center, it can contribute to improved motor reliability and reduce maintenance costs. Precise speed control is essential for many industrial applications where it is necessary to maintain a constant speed or to vary the speed of a motor in response to changing conditions. Variable frequency drives provide precise speed control, allowing motors to operate at their desired speed with minimal variation. By classifying a variable frequency drive enclosure as a motor control center, it can enable precise speed control and improve process performance. Power distribution is the process of delivering electrical power from a source to various loads. Motor control centers play a crucial role in power distribution, providing a centralized location for distributing power to multiple motors. By classifying a variable frequency drive enclosure as a motor control center, it can integrate into the power distribution system and provide efficient and reliable power to motors. Electrical safety is paramount in industrial facilities, where electrical hazards can pose a significant risk to workers. Motor control centers are designed with safety in mind, incorporating features such as disconnect switches, overcurrent protection, and grounding to minimize the risk of electrical shock or fire. By classifying a variable frequency drive enclosure as a motor control center, it can benefit from these safety features and contribute to a safer working environment. Automation is the use of technology to control and monitor industrial processes, reducing the need for human intervention. Motor control centers are often integrated with automation systems, allowing for remote control and monitoring of motors and other equipment. By classifying a variable frequency drive enclosure as a motor control center, it can facilitate integration with automation systems and improve overall process efficiency. Maintenance costs can be a significant expense in industrial facilities. Motor control centers can reduce maintenance costs by providing a centralized location for monitoring and maintaining motor control equipment. By classifying a variable frequency drive enclosure as a motor control center, it can contribute to reduced maintenance costs and improved equipment uptime. Equipment uptime is a measure of the amount of time that equipment is available for use. Motor control centers can improve equipment uptime by providing reliable motor control and protection, minimizing the risk of equipment failure. By classifying a variable frequency drive enclosure as a motor control center, it can contribute to improved equipment uptime and increased productivity. Industrial processes are the steps involved in manufacturing or producing goods. Motor control centers play a crucial role in industrial processes, providing the power and control necessary to operate motors and other equipment. By classifying a variable frequency drive enclosure as a motor control center, it can contribute to the efficient and reliable operation of industrial processes. The electrical system is the network of components and equipment that delivers electrical power to a facility. Motor control centers are an integral part of the electrical system, providing a centralized location for controlling and protecting motors and other electrical loads. By classifying a variable frequency drive enclosure as a motor control center, it can integrate into the electrical system and improve overall system performance. Electrical hazards are potential sources of injury or damage caused by electricity. Motor control centers are designed to minimize electrical hazards by incorporating safety features such as disconnect switches, overcurrent protection, and grounding. By classifying a variable frequency drive enclosure as a motor control center, it can benefit from these safety features and contribute to a safer working environment. Short circuits are abnormal electrical conditions that occur when there is a low resistance path between 2 points in a circuit, causing a large current to flow. Short circuits can damage equipment and pose a risk of fire. Overcurrent protection devices in motor control centers are designed to quickly disconnect the power supply in case of a short circuit, preventing damage and minimizing the risk of fire. Overload conditions occur when the current in an electrical circuit exceeds the rated capacity of the equipment, causing the equipment to overheat and potentially fail. Overload protection devices in motor control centers are designed to protect motors from overload conditions by disconnecting the power supply when the current exceeds a determined level. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. Grounding is an essential safety feature in motor control centers, as it helps to prevent electrical shock and reduce the risk of fire. The local authority having jurisdiction is the government agency or organization that is responsible for enforcing electrical codes and regulations in a particular location. Consulting with the local authority having jurisdiction is essential for ensuring that electrical equipment complies with all applicable regulations and codes. In Westchester County, New York, electrical installations must comply with the New York State Uniform Fire Prevention and Building Code, which incorporates the National Electrical Code, also known as NEC. The NEC provides detailed requirements for the design, installation, and maintenance of electrical systems, including motor control centers.